Today we are going to learn how to calculate the pH of a strong acid. In this example, we are particularly focused on calculating the pH of a strong acid. Remember in class we have talked about that there are two types of acids, strong acids and weak acids. The method that we're going to discuss now applies to strong acids. You can also calculate the pH of weak acids, but it's a slightly different procedure than what we're going to do for a strong acid. Okay, so let's go ahead and go forward. So again, let's review. What is a strong acid? A strong acid, when combined with water, produces hydronium ions, and the anion floats off by itself. So how a strong acid works, what that means is that every single one of these acid molecules that you dissolve into your solution will be converted into hydronium ions. That is a definition of a strong acid. So if we start off with, say, 1 molar hydrochloric acid, that means that we will then end up with 1 molar of hydronium ions, because that's the definition of a strong acid. 100% of the atoms of the acid will be converted into hydronium ions. This is really important when it comes to calculating pH. So the formula to calculate pH is the pH of a solution can be calculated by taking the logarithm of the concentration of hydronium ions and multiplying it by -1. All right, so let's go ahead and look at an example. All right, I'm going to leave our reference formula up here for us. pH equals the negative logarithm of the concentration of the hydronium ions. And our question is going to be, what is the pH of a 0.45 molar HCl solution? So the first thing we need to do is figure out what the concentration of hydronium ions will be. Now remember, for a strong acid such as HCl is a strong acid. This is fairly straightforward. Remember, when you're working with a strong acid, all of the acid atoms are converted into hydronium ions, so we right away know that the concentration of hydronium ions for this solution is going to be 0.45 molar. So now calculating the pH is fairly straightforward. We just plug in our concentration of hydronium ions into our formula. The pH will be the negative logarithm of 0.45. So we can then get out our calculator, take the logarithm of 0.45, and we see that the pH will be a negative sign times negative 0.35. I rounded the logarithm to 2 significant figures because we started the problem with 2 significant figures. So we now see that pH will be -1 times negative 0.35. A negative times a negative is a positive. So the pH of this solution will be 0.35.